So when I was walking around, I noticed some of you did not number your pages like I asked you to in the beginning of that video. I'm not going to make you go through it again, but if you end up getting assigned homework and you're like, well, I don't know what page that was, I'm not accepting that as an answer and you're getting a 0. So the pages should go nice and in order, 1 through 34. There's a couple pages that were mislabeled or double labeled, but in the end, they just went pages 1 through 34. So don't get confused by that. So going through the homework, I don't think we need to spend a super huge amount of time doing this, but I just want to check how you guys did. What'd you get as the eccentricity for this to the nearest 1,000th? Okay, what numbers did you have on top and bottom, just so I can?
2.9.
Okay.
And 8.5.
Okay, so that's why your answer is slightly different than me. And I think I explained this the other day. This is why I absolutely hate these questions, because I now have to do your math. And you said this was your answer? 0.341. When I do this, I always have to make sure that you rounded correctly. I had slightly different numbers, actually only one slightly different one. And then I got that. Either one is perfectly correct. Just make sure you're rounding correctly to the 1,000th place. Now, 2 is a perfect like Regents question. It kind of combines, in fact, I've seen this combination of questions multiple times throughout the years I've taught, where they first make you calculate it and then they compare it to one of the actual planets in our solar system. So how did you compare this to the eccentricity of Mars, which, by the way, if you looked up Mars has an eccentricity of 0.093. How did you word this is kind of where I want to go with it. What? Really? I'm loud? Have I mentioned how I'm quiet compared to my mom? My mom would put me to shame. Yeah, she's real loud.
Both the average.
Hey.
Mr. Joe was playing with a video on acting like that. I can hear you over that.
Good, I can project my voice. Anyway, how did you word this? Like I was saying, I want to make sure your wording was okay, because that's where I think people are going to get in trouble with this type of question.
Greater.
So what word for word, what'd you write?
It has a greater eccentricity than Mars.
It has a greater
It referring to the
eccentricity than Mars. This is correct. I am going to caution you, and Gabe caught it there once I had him read it out loud. Using the word it worries me a little bit in questions like this. In this case, it does work because it did want you to state the eccentricity of the given one compared to Mars. But oftentimes when people are doing these questions, sometimes you're confused, like, am I comparing Mars or the ellipse? So instead of saying it, I would say the given ellipse. Like I would actually say it out loud, because you could also say it, you could reverse it and say that Mars has a smaller.
I think it would flag that Mars, but I suppose it has a greater eccentricity, then they wouldn't know.
Yeah. So yeah, nothing you did was wrong. I'm just cautioning people, because this is a place where people mess up. So I really would rather you guys not use the word it ever. Tell me what you mean by it. Yep, there are more right answers, by the way. What is that, where you were going to go with it? Yes, and that was actually going to be my follow-up question. My follow-up question was going to be, does this ellipse have a more oval or a more round shape than Mars? And Darius already answered it. This ellipse is more oval. And that would absolutely be an accepted answer. Or you could reverse it and say Mars has a more round or circular orbit. That is something you have to make sure you remember, because that might be the question they ask. Is it more round or is it more oval? And it's more round if it's closer to 0. So the smaller answers are closer or are more round, and the larger answers are more oval. So those are two concepts that these questions, I've seen this asked over and over and over again. First, calculate it, then compare it, and make sure you know what shape that is, round or oval. So on the top of the next page, we just had to calculate the eccentricity. Now, normally when you do this, they are going to make you go to the nearest thousandth, but also just make sure you're capable of rounding those numbers to the nearest thousandth. And when you did that, can you guys show me on your fingers what you got for number 3? Yep, seeing almost all the right answers. That does round to 0.2. When I did it, I had 1.4 divided by 6.8, and that gave me that answer, which does round to 0.2. From yesterday's notes that you took from the video, which one of these has the greatest gravitational attraction? Yeah, show if you guys got it. It is answer A. Can somebody explain to me why A has the greatest? Yeah, it's the closest. The closer they are, the stronger the gravitational attraction. Which then kind of leads into question 5, because how close or far away they are affects their velocity. Which location will have the fastest velocity? Also A. So when I did this, I added some labels. A is the fastest. Which one's the slowest? Somebody besides Gabe. Oh, okay, good, everybody. So this is the slowest. So what, for question 5, it wants to know, as it revolves in its orbit from A to D. Now they do tell you it's going this way. So it wasn't going just from A backwards to D. You had to follow it around. And one thing I did when I labeled it, what happens when you go from A to B to C? So when you go from the fastest to slowest, this path, the speed is going to decrease. What about this part of the trip? This one is where it's going to start to speed up. So then once I get to this question, I can see that that is answer 3. It will decrease, then increase. Here's my answer key. I actually did all of that on my answer key. Adding some labels, adding some notes to your question will just help you keep it straight in your head as you're going along. Something I highly recommend. Now for this one, it didn't tell you to calculate the eccentricity. So did you, or did you just wing it? Yeah, you have to calculate them still. There's no way of winging it because they all look either really circular, like this one up here. Didn't that look like a circle? To me, it did. It looked pretty much like a circle, and it still had an eccentricity bigger than Earth's orbit's eccentricity. So we can't just look at them. You do have to actually calculate them. And when you calculate it, which one is it closest to? What'd you guys say? Yeah, you guys got this. It's Mercury. Maybe I should just leave and teach you by video more often. Shut up. That was not a question. Which one of these is closest to the moon's orbit? What'd you say? Okay, I think a few of you fell for it. Hey, Lillian, can I ask you a question? Sorry to put you on the spot. Did you check out Saturn's, or did you stop once you got to Jupiter?
I mean, I've been doing.
Huh?
I've been doing it.
Oh, well, good random answer, Lillian.
Oh.
Way to be honest. Earlier today, everybody admitted that picked Jupiter because Jupiter has a eccentricity of 0.048, while the moon is 0.055. And compared to Earth, that's way closer. So a lot of people just picked Jupiter because it was close. But if you kept going, Saturn was even closer. So that is Saturn. You know how to do it?
Yeah.
Sorry to put you on the spot there. Again, in the end, it says describe the eccentricity of D compared to our planets. Again, did you just wing it and just look at it? No, because if you look at it, to me, those all look like they're circles. Yes, D has a bigger circle, but it's not asking about the size of the circles. It's asking about the shape of the circles. Still coughing. A lot less though, have you noticed? Gosh, you guys are brutal. When you do the math, I got an eccentricity of 0.316, what might not be exactly the same as what you guys got. Which is clearly greater than any of the other planets in our solar system. So to word that one, I would say planet D's orbit is more eccentric or has a greater eccentricity. Did anybody just say planet D is orbit is greater? So by saying it's just greater, I know what you mean. But that to me sounds like you were talking about size of it. And yeah, it is bigger, but that's not what the question asked. Okay, gonna make it. There's the answer to that. So it did ask, make sure in the end you had to describe where the force was greatest and where the force was least. So make sure your answer answers the question they asked. It's greatest when it's close, less when it's far away. So just make sure you do what they're asking. I think we can just kind of knock out the rest of these. Here I had 0.7 for number 10. We good with that? And 0.68, number 2 for 11. We good, or should I go through that one?
We're good.
For the actual shape. I don't know, but it's still way less. Like I'm actually able to breathe today compared to the day I was here last with you guys. And actually until right now, I've been great all day. So for the shape, oval works, ellipse works. There's other right answers. Did anybody put anything else? Okay, like a slightly oval circle would work, or a squished circle, as long as you didn't say a circle. Now some, huh? Not a perfect circle, honestly, would be a good answer. Now, I'm not teaching you number 13 until tomorrow, but just for the record, it's winter. So if you recall, I was really specific about this when we were talking about angle of insolation and when it's warmest and when it's coldest. And a bunch of people wanted to tell me it's cold in winter because that's when we're far away from the sun. But technically, we are a little bit closer to the sun during our winter than we are during the summer. So how far or close we are to the sun does not affect our temperatures. Huh? Say it one more time.
How long the sun?
Yes, that's part of it. But again, it has nothing to do with how close we are. That's the moral of the story. I didn't teach you anything about apparent size. I kind of just assumed you guys knew that when things are farther away, how do they look size-wise? They do look smaller. Like, for example, right now I'm going to use Izzy as an example. She's in the back of the room and her head looks about that big to me if I tried to measure her head. Whereas if I look at Cooper's head, who was out doing a flip during my class, his head looks about this big. Why does Cooper's head look so much bigger than Izzy's? Because Cooper's closer. Hey, be nice to Cooper. He only skips my class, not your class. What you did need to know were the vocab words. Perihelion is when the sun is, or the earth is closest to the sun. Aphelion is when the earth is far away. So this is asking what happens to the size of the sun when it goes from being close to far away. And you should know that it'll look smaller. And in the end for question 15, you just had to say something about when it's close to the sun, it's faster. Anybody have a wording there they're not sure is good
The more velocity.
instead of faster? Yeah, perfect. How'd you guys do with that, even though I wasn't here to teach you? We ace it?
Yeah.
Did you guys like my rulers I had available for you?
Yeah,
Anybody else need one?
I use the real one.
You did use a real one? Oh, so you finished in class?
They're right there.
Yeah. So if anybody ever needs a ruler, I've got plenty of my paper rulers for you. Aren't they cool? No. We will have more homework with those, so if you do need a ruler to take home, help yourself. All right, because we were jumping all around, we have officially gotten all the stuff I wanted to teach you in an emergency. In other words, I wanted to teach it to you before you got to lab, which I think everybody might be starting that lab starting either tomorrow or Monday. So we're gonna go back to the beginning of the packet. We're on page 2 here. And I think, is everybody here or did somebody go out to the bathroom?
We're still here, though.
Yeah, yeah. I think we're gonna take a quick field trip outside. All right, here's the rest of those notes, all the things we just observed outside. So the celestial sphere, it's that imaginary dome that surrounds the earth. In other words, it's the sky. Not gonna lie, that's all it is the sky. It's 2.
I don't have it.
Where's your front cover of your text?
I don't know, my tag starts on page 3.
So my guess is, oh, you recycled all those pages.
Oh, wait. Is this it?
Probably.
Miss Ritz, we went in a minute and a half early.
Well, you better write quickly then.
Where did you?
All right, so like I said, celestial objects. They're any object on the sphere. So in other words, any object in the sky. The sun, the stars, the moon, the planets, a bird, an airplane. Anything that's in the sky will count as a celestial object.
How high is the sky?
I don't know.
So if you jump, does that mean you're in the sky?
Sure.
Okay.
You are now a celestial object, Blaze. You're not.
Why?
Cause I said so. Cause you lost the race to Blaze.
Okay, in my defense, we had to do squats and.
No.
Squat should make you stronger.
Yeah.
Wait, Dave,
well,
you do track, right?
What?
You do track and cross country?
All right, we got that all? Altitude, height above Earth's surface measured in degrees. The most famous altitude you have to remember is the altitude of Polaris. Remember, it equals your latitude. We just reviewed that a few days ago. It's in one of the homeworks you did.
You get excited to go back when you had all that opportunity outside, you just been doing one. You feel more of a rebel doing.
If you had done one, you could have been a celestial object because you would have had,
Eric's doing
Yeah.
it now. The sheep over there.
My mom just likes.
that's the lanolin in there.
What you said.
That's what people are allergic to usually. Zenith, like I was saying out there, it is just the point directly over your head. So the zenith is different for every person. It's just directly over your head. What you see directly over your head will be different than what somebody in Alaska or Florida sees directly over their head. No, we're gonna do one more thing. And for this, could you grab your reference table? Page 4, I think,
There's nothing.
of your reference table. Here, I did forget that we have this, slide. This is the last slide of notes, though. We've already talked about direct rays of the sun. If I was to throw a water balloon and I hit Darius with a direct shot, what's that mean?
And I'm projecting.
It's about to get soaked.
I hit them right on. Direct rays of the sun, they're when the sun will hit you right on. In other words, at a right angle. It's when the sun is directly overhead. And as we talked about last chapter, which was on, I think it was on the test, not just the retake. This never happens in New York. In fact, it never happens in any of the United States. Sun is never, ever, 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 ever directly over your head if you're in the United States. Not even at noon. And the last thing I want you to do is on that globe, can you please label those, was there 7 places? The equator, the North Pole, the South Pole, the Tropic of Cancer, the Tropic of Capricorn, the axis of rotation, the Antarctic Circle, and the Arctic Circle. If you need help with this, that's why I had you grab page 4 of your reference table. They are labeled on the right side of page 4. Or at least most of them are. Page 4 of your reference table, the ocean current map.
Yeah.
Has the equator, the Arctic Circle, the Antarctic Circle, the Tropic of Cancer, and Capricorn labeled. Be careful because the Earth is tilted in that picture. So since the Earth is tilted, it might disorient you a little bit. We're used to looking at pictures of the globe like they are on page 14 of your reference table, where it's nice and straight and perfectly up and down. But in real life, the Earth is tilted. So when it tilts, the equator's still in the same spot. It's still the line going down the middle of the globe. But yeah, it's not perfectly straight. So the equator is that one. Which one of those lines is the North Pole? The very top. So the North Pole, because the Earth is tilted, will be leaning off to the side. Making the South Pole also leaning over to the side. How about the Tropic of Cancer? Where was that one? It's the one directly above the equator. How about the Tropic of Capricorn? Below the equator. I think I go with the axis of rotation. No, I don't. Yeah, I do go with the axis of rotation next. Which one is that? The one on the left. Yep. And how about the Arctic Circle? Yep, that, oh, I guess I went Antarctic first. So Antarctic is that one directly above the North Pole. And Arctic is, or I'm sorry, above the South Pole. And, oh, copy this. So Antarctic's down here, Arctic's up here. Oh, this is where we're gonna finish off for today, yeah.
You agree, but I'm not gonna try.
Then if you're not going to